Share screen.
Yes.
Okay, everyone see that?
Yeah, just go into present mode and we should be sweet.
Okay. Okay. Loading. Okay, everyone see that?
Yeah, it's there now. Thanks, Ken.
Okay, righto. Welcome everyone. Tonight I'm going to talk about the other Spacelab. We've heard of Skylab, but this is Spacelab. It's pretty well taken for granted. We've seen it though through the space shuttle and what it in the interior, but I don't know how many people actually understand the history of and the origin of the Spacelab. So my talk will be on the origins from the late 60s until the first mission. I'm not going to talk about the whole one because that's just too much. So I'll stop at the first mission. Oh, if you have any questions or any corrections, indeed, use the chat line. Okay. Let's start from the beginning by beginning at the end of the Apollo missions. Its origins go back to a time when Apollo was at its peak, like the Apollo moon missions, and already NASA was looking ahead to see what they would do next. Men were walking on the moon and Skylab was on the horizon. Okay, let's set the scene. Although we've been walking on the moon, moonshots were beginning to be cancelled. So that's cancelled. And Skylab hasn't been launched yet, but it was in the future. But of course, it's only ever meant to be a temporary thing. The race to the moon had been run and won, so there was a political will had changed. So by now, Russia, or USSR, I should say, had given up any thought of landing humans on the moon. Money, it's always about money, isn't it? The money ran out, basically. There was no longer the political or the public will to spend vast amounts of money on space flights because we'd already achieved the goal of landing a man on the moon and returning him safely to home. There was now felt there was a need to include other allied nations in NASA flights, allied being Cold War allies, of course, because the Soviet Union had their allies, didn't they? Cold War competition with the USSR. The Soviet Union had moved into space station development already. And so the US was feeling like they should be keeping up. Space-related experiments and observations. There was a movement into space research and observations, which the USSR were already doing. Spacelab was to fill that need. They needed something to aid. So the shift was to space research rather than exploration. 9. A space station like the Soviets had was a long way off for NASA. Even though the ISS was quite large, it was still a long way off. And the Soviets were in them, they had space stations already. Okay, the politics and the timeline. The earliest thoughts of a space laboratory first rose in the late 60s. They were looking at Apollo program, post-Apollo program. NASA Administrator Dr. Thomas Paine traveled to almost 20 countries to assess interest and possibilities. And many programs were considered, and as expected, all were expensive. The high cost meant a multinational program. Also, the Soviets, this is my view, this is not official, this is what I feel. The Soviets were sending up non-Russian cosmonauts, primarily Eastern Bloc, and NASA had yet to send up a non-US citizen. So there was a political impetus there to put up people who weren't US citizens, in my view. The permanent space station was delayed, of course, because of the money. Instead, it was decided that a space shuttle would be both economical and useful. Within the space shuttle would be a space laboratory, and that's where the other countries came into it. In 1969, President Nixon made an offer to ELDO/ESO, which is now ESA, European Space Agency, to develop and build 2 space-based laboratories, identical space-based laboratories, at a cost of $1 billion for both of them. So it's $500 million US each. So you can see the list of countries there. Each country offered a varying amount of money, and I'll go into more details about that later. And in 1973, a formal agreement was signed by the Europeans and the US. It was decided that they would have to run in parallel with the development of Space Shuttle, because as it was going to be in the cargo bay of the Space Shuttle, it had to be developed parallel with it. So although it was built in Europe, it ran parallel with the Space Shuttle. I'll just give you some ideas of some concepts of what went through. This is obviously a very early one. The Space Shuttle looks vaguely like it. You can see Space Shuttle isn't exactly like the one we know, but it's pretty close. And they had a pretty good idea of what they wanted very early on. So you can see the tunnel and the space laboratory and 2 space shuttles at the same time. I wasn't aware of that, but anyway. Here are some rather optimistically large payloads. I'm not quite sure how they're supposed to fit in the cargo bay, but nevertheless, they were optimistic times perhaps. And this shows there's one there you can see that shows a space shuttle flying free from the, I'll just move that, from the space shuttle. Whoops, that's not right. I'll just move this. Sorry, fellas. Oh, excuse me again. So it's flying free from the shuttle. I'll talk about that later. And the bottom one shows no tunnel and no pallets. Okay, so that's another one you should think about. So it's important to point out the Spacelab was always intended to be a laboratory, not a habitat. Okay, there were thoughts of making it float freely, like here, but none were seriously considered. And I'll go and explain that afterwards. So keep in mind, it's not a habitat, it's a laboratory. Okay, so the construction was done in West Germany being the old Cold War thing. And you can see where, even though these are pre-construction illustrations, they do show how it's done. You can see the being slid into the cavity there, and important men looking on in their suits. At the height of its manufacturing, more than 2,000 people were employed by over 40 subcontractors throughout Europe. Okay, and the contractor was awarded to Erno VF-Fokker. That's 3 things there, in competition with MBB. The plant was in Bremen, in West Germany, and that was the headquarters for all aspects of the Spacelab design. So it's construction, component development, and the assembly. So the Germans really contributed, the single largest contributor. It was more than 50%. It was the single largest contributor to the development of the Spacelab. I like this illustration because you can see there are various people. There's men working inside the Spacelab. There's 2 up in the flight deck, and there's one in the tunnel, and there's a person in there in the living quarters, and there's even someone doing an EVA. They're a very busy lot, aren't they? Okay, here's a hang on, go there. Sorry, my screen's playing up. Okay, so this is a line drawing the module. You can see how it's, hang on. Oh, what have I got here? Okay, yep. So there's you can see there are two segments. There's a core segment and an experiment segment. And you can see here where the tunnel connects to the laboratory, and there's a viewing port and high quality window. That was for photographic work. And this is an airlock if they need to go outside. So it was a shirt sleeve environment for scientific experiments and observations. And two segments, tunnel entry to space shuttle, viewing window, airlock to exterior. Okay, this shows the construction method of the instrument. So you can see at the top where the interior was slid into the exterior section, and it was a cap was put on the end, on both ends. It shows a tunnel, but that wasn't put on at the time in Europe. It was put on in the US. So this is the 1974 idea. So they're pretty well on the track by 74. They knew what they were doing. Okay, this gives a better idea. It's a better illustration. Gives the idea of scale there with the man standing next to it. And you can see a lot of detail inside the cutaway there. Okay, so as I said, I've got it written. The Spacelab was not able to be deployed free of the orbiter. He said, did consider free-flying configuration at various times over the years. However, because they kept it, if it made a habitat, that would have been more expensive. It would have had to be self-sustainable, which was cost prohibitive. And for scientific experiments, it wasn't really entirely necessary. So they obviously took the cheaper line. So there's a pallet for holding things. When we talk about Spacelab, it isn't just the module. This is an important thing to consider as well. There's various other things that came with it, and the other most important thing was the pallets. You can see there, if you can tell, there are two pallets. They were built and finished before the module, so I end up flying before the module. But these were to hold various things from obviously exterior experiments like telescopes and various other exterior experiments. And there's the igloo. Now whenever the pallets flew without the module, they need to have the aeronautics to help it move around. So all those were housed in the igloo. That's that little thing there. So it's 3 meters high by 1.5 meters in diameter. It's a pressurized container. That was usually where, that was only ever used when there was no module. So we could fly pallets and modules, but no need to fly modules, pallets and igloo. Okay, the instrument pointing system is another aspect of the Spacelab. It was obviously, as you can see, for a telescope there, and there's a gimbal at the bottom there. You can see the pallet, and it's attached there. So they built this, the IPS, and they usually put on the payload, which is usually a telescope or some sort of optical sensor, some sort of sensor. So a lot of observing the sun and the Earth, because of, as you may already know, the space shuttle bay, cargo bay, faced towards the Earth. So for that reason. And there we have it, the pallet. The pallet was built by the British Aerospace under contract, and was first flown STS-2 in 1981. It was a full 2 years before the module, obviously because it was easier to build. So STS-2, it didn't take them very long to put them to get it up there in space. I'm pretty keen to use it. And here we are, it's being moved. It gives you an idea of scale as well. Looks like it's got some glad wrapped around to protect it. I'm assuming that's going from Germany to NASA, but it's hard to tell. Okay, the tunnel. I'm including the tunnel because it involves a Spacelab, but it wasn't an ESA project. It's that was to go from the cabin of the shuttle to the space module. It was it says there 1.1 meter diameter. They crawled through the tunnel to get into the space module. Now it was various lengths because a space module could be, as you know, I showed you before, could be 2 or 1 module. It's usually 2, so it's data length. Now the modules never flew without the tunnel, and this was because of the center of gravity. It had to be meant that the Spacelab module had to be further back. So it had to have a tunnel connecting to the cabin. It couldn't just connect directly to the cabin, otherwise it would be top heavy. Okay, I've got a few configurations on the right hand side. You can see where it's top, there's 1 module, 2 pallets, 1 module, 3 pallets, 2 modules, no pallets, and on down the bottom till you got 5 pallets. Now, as far as I can understand, they never did fly 5 pallets. I think the most they ever flew was 3, but that's not included in my talk, so I didn't look that far. Okay, here's the main deal, the pressurized module. So each segment was 2.7 meters long and 4.06 meters in diameter. That's 2 sections there. Now, as I've got the quote there from Wikipedia, West Germany provided 53.3% of all Spacelab costs and fulfilled 52.6% of all Spacelab work contracts. So they're busy countries. A busy country, considering that there are 9 countries involved, and Britain contributed 12%. So the other countries did their bit, I suppose, but it was pretty much a West German thing. Now I think that's in the space shuttle. It looks like it's ready to be flown. Couldn't quite work that one out. Looks like the clamshell doors there. And that's obviously is the entrance to the tunnel before the tunnel is connected. Okay, now here obviously it's in the space shuttle. We're installing it. So it's all those white suits there. And here's the tunnel being put in. As you can see, it has like a Z shape because it couldn't directly line up with the shuttle. So you wouldn't want to have claustrophobia, I suppose, cooling through there, but weightlessness probably gives you a feeling of more space. I'm not sure. I've never been there. And here's the IPS that was built by Dornier in Germany. So it's they connected whatever they need to connect with that went on here. And this piece, this is where it's attached to the pallet. That's on display there in Space Museum. That's not the Space Museum right in Washington DC. It's in the extension. If anyone's ever been there, it's behind the space shuttle. And here they are. The crew of oh, I can't get rid of that. Okay, so it's called it's Space Module Flight number 1, but STS-9, 1983. We have Commander John Young, the most experienced, and there was 3 there who had never flown before. Yeah, I'll give you the details of the others later. Okay. So they're a pretty good crew. Come on. Waiting for things. There we are. Okay. Mission crew. So the 2 crews are 12-hour shifts. We have John Young, the commander. It was his 6th flight. He'd already flown 2 in Gemini, 2 Apollo, and this was his 2nd shuttle flight. He actually also flew the first space shuttle flight as well, so an extremely experienced commander. And it was his last flight, his 6th and last flight. So I think he'd all up 18 years in NASA. I'll have to correct that. Someone can correct me. It was certainly his last flight, and it was his 6th. Brewster was a pilot, and this was his first flight. Now the other 4, 2 payload specialists and 2 mission specialists. So they were the scientists. Lichtenberg and Merbold, they were there on their first flight, so there's 1 crew. Merbold was also they were the first 2 non-NASA astronauts to fly in the shuttle, so there was another first. And Merbold was the first non-US citizen to fly in the shuttle, so he was West German. And Garriott, I don't know how to pronounce his name. He was his 2nd flight, and Parker was his 1st. So we've got some pretty good scientists there, and a very, very experienced commander. And you'll be glad he was there, as you'll find out at the end. Okay, the title was Microgravity Research. I'll just read through it and give details as I go along. There's 72 scientific experiments. It's quite a lot. It's atmospheric physics, plasma physics, astronomy, solar physics, material sciences, technology, astrobiology, and Earth observations. So it was designated entirely to space module work, Spacelab module work. It was a test for the Spacelab basically, and it was Columbia. So launch date was 28th of November, 83, and landing date 8th of December, 83. So 167 orbits, traveling 60.9 million kilometers. And it flew longer than it was expected. It went for 10 days, 7 hours and 47 minutes and X seconds. Of course, it was launched from Kennedy Space Center and it landed at Edwards Air Base. Now I'll just sort of go through all these photographs to give you an idea, just to show. So, oops, back again. So there's Commander there, John Young there. You can see on, he's looking at the fellow on the right, he's looking at the sides. The equipment was, the experiment was stored on the side. I say side because of space, zero gravity is hard to say, but we'll call them the sides. And they're usually on drawers or in cabinets on the side. There were human experiments as well, of course. That's why he's thinking around his head. And at the bottom was the storage compartments. Most of the storage compartments on the bottom, the floor, quote unquote. So there's all these experiments and scientific instruments on the sides, and the storage compartments on the bottom. And there's the little logo on the side there. That's the ESA NASA logo. So there's another some more instruments and see, get a better view of the experiments going on with his head. I don't know quite what he's doing. I couldn't find that out. There's another view there. I can give you more detail, but I thought I would just, I don't want to bore you too much. There's obviously there are solar experiments. It's quite a common thing back then to do solar experiments, and infrared spectrometry and imaging spectrometry observations. What else did they do? I've got a whole list of things they did. Solar constant radiometer, if anyone's interested. Active cavity radiometer irradiance monitor. X-ray spectrometer. Very wide field limit. X-ray spectrometer. Ultraviolet space telescope. There you go. So, okay. Now, the adventure wasn't over. It was extremely successful, as I said. It lasted for a day longer than I expected. Those guys are already getting stuff done. The excitement really came towards the end. There's John Young commanding the Columbia back home. They're lucky to make it back, it seems like. There were 3 near misses, just 4 hours before landing. On one of the flight control thrusters crashed. Computer controlled thruster crashed. Then a few minutes later, another one crashed. So the thrusters controlling direction both crashed, but the backup worked. And then just before landing, just like minutes before landing, 2 of the 3 auxiliary power units caught fire, causing major damage to the compartment. In other words, they landed while on fire. I'm glad John Young was there to help. And they landed on runway 17 at Edwards Air Base on the 8th of December, 1983 at 3:47 p.m. Now, Spacelab components eventually flew on 22 missions, so that's including all modules and the pallets. The module itself, they flew on 16 missions. There were 2, of course, built. As I mentioned before, I forgot to mention earlier. The first one, like the ESA gave to NASA in exchange for direct access to all the research that was done. And NASA paid for the second one. The turnaround time for the Spacelab was the same as the turnaround time for the Space Shuttle, which is 2 weeks. Obviously, it took a combine to make them both workable. They work very, very closely with Space Shuttle. It's very much tied into Space Shuttle. And in my short conclusion, I quote, "It would be one of the most successful missions of the Space Shuttle, this mission, Space Shuttle era, and set in place a strong future of space research." Thank you. Hope you enjoyed my short talk.
Thanks very much, Ken. We've got, I suppose what we could do is potentially put the first video on and maybe do some questions, or do you want to do questions now? What do you think?
I think that we've watched, so certainly watch the NASA one, explained a lot.
The NASA one, do some questions and
yeah.
Yeah, that sounds like a good choice. Do you want to cue it or I do?
I might have to get you 2 off.
That's all right. I've got, go and get
You've got it?
Yeah, just all right.
Right.
I'm going to have to share the presentation. So, yeah,
Oh, here, I've got it.
You got it?
I think I've got it. No.
That's all right. I'll do it.
Thanks, Frank.
No problems. Okay, go for it.
Yeah, that's it.
Before man traveled in space, energy from the sun was thought to be constant. Then, scientific instruments rising above the atmosphere recorded great shafts of energy flashing out from the sun like beams from a lighthouse. Energy affecting communications and perhaps the weather on Earth. Small levels of pollution were considered unimportant until high-altitude research showed that a few parts per billion of Freon could reduce protective ozone in the upper atmosphere. In space, we learned things which were obscured to us on Earth. But space research using one-shot rockets has been expensive and somewhat inflexible as scientists sat on Earth while astronauts worked their apparatus. Now there is a reusable space shuttle capable of making repeated trips into space. And there is a space laboratory which takes advantage of this economical transportation to and from orbit. It is called Spacelab. It fits in the shuttle payload bay and converts the shuttle into a versatile research center. Trips into orbit can be frequent. Scientific objectives can change for each mission. Scientists, not just career astronauts, can ride the shuttle and work in the lab. Spacelab is truly a new generation of research laboratory. In the early 70s, NASA began developing a national space transportation system. In Europe, ESA, the European Space Agency, was interested in collaborating. What major contribution could Europe make? Many possibilities were considered. Ultimately, Spacelab was selected. This laboratory would be versatile. It would be reusable. It would meet the demands of the international scientific community exclusively to do research in the broadest range of disciplines. It would have a pressurized room where the scientists themselves could work without cumbersome spacesuits. It would have platforms where instruments would be exposed directly to the airless, cloudless, low-gravity environment of space. Now a reality, Spacelab is a European development involving European industry in space technology. It was assembled in Bremen, Germany, from parts made in all participating ESA countries. Erno is the prime contractor. Because the Spacelab fits in the shuttle, NASA was also involved. Marshall Space Flight Center led the development for NASA and managed development of an access tunnel and support hardware and software for the lab. And because Spacelab is new, Marshall designed a series of test instruments to monitor the Spacelab's performance during the first 2 missions. Spacelab is versatile. It can be composed of any of several modular units which fit into the bay to meet the needs of a particular scientific mission. There is the pressurized laboratory, called a module, containing instrument racks, utilities, computers, workbenches, and controls for the conduct of research. There also are outside platforms, called pallets, for experiments which need direct exposure to space. This mix or match design makes the Spacelab able to accommodate a wide variety of scientific investigations. At mission's end, the pressurized modules and the pallets are fully or partly stripped of one set of experiments, and new ones are installed for the upcoming mission. The laboratory module can hold more than 5 tons of experiment hardware. More than 9 tons can be carried in the pallet-only configurations. As many as 5 scientists and science astronauts live in the shuttle orbiter, along with the commander and pilot. They pass through a tunnel to go to work in the laboratory module. Pallet-only missions are operated from inside the orbiter. In every way possible, Spacelab minimizes the amount of modifications needed to take ground laboratory experiment equipment into space. The scientist or principal investigator can monitor his or her experiment from Earth. Voice, data, and video circuits will allow the investigator direct involvement during an experiment. Procedural changes based on observation can be passed up to the onboard science crew for execution. In some cases, changes can be made by the scientist from the ground. It's the next best thing to taking some 70 scientists into orbit.
I mean, there might be a little risk of implosion or something like that.
Mission 1, the maiden voyage. Its purpose? Test the laboratory. Prove the thousands of electronic parts, pumps, fans, and valves, as well as the computers which service the experiments. Demonstrate new research techniques developed specially for Spacelab. Conduct more than 70 investigations in 9 days. It's a joint mission of NASA and the European Space Agency. Each agency has sponsored about half the payload. 11 European countries, Canada, Japan, and the U.S. have experiments on Spacelab 1. Scientific diversity is important on Mission 1. It tests the lab's ability to serve the full range of disciplines. Equally important is the expansion of man's scientific knowledge. Mission 1's experiments were selected for their scientific merit by international peer review panels from over 800 proposals.
I want to welcome everybody to ALPA. It is always a pleasure for me.
Once the experiments were selected, the investigators formed a cooperative body called the Investigators Working Group, or IWG. One of the group's tasks was to recommend which of the many scientists, only one from Europe and one from the United States, would fly the first mission. 2 alternates also were selected. Called payload specialists, these career scientists would learn details of each experiment over the next 4 years. Dr. Ulf Meerbold of the Max Planck Institute in Stuttgart, Germany, and Dr. Byron Lichtenberg of the Massachusetts Institute of Technology were chosen as flight payload specialists. Dr. Wubo Ockels of the University of Groningen in the Netherlands and Dr. Michael Lampton of the University of California at Berkeley are alternates. These payload specialists have learned the background, objectives, and procedures for each experiment. They have become personally acquainted with each principal investigator. They have become each scientist's representative in orbit. Mission 1 also has 2 scientists-astronauts for NASA, Dr. Owen Garriott and Dr. Robert Parker. They are called mission specialists and are responsible for operating the systems of the laboratory itself and for coordination with shuttle pilots John Young and Brewster Shaw. They trained as much as possible with the payload specialists and would spend much of their time conducting experiments with them. What would it be like? This simulation at the Marshall Space Flight Center covers a 24-hour slice of the 9-day mission. Marshall is responsible for managing the early Spacelab mission.
Going to get information back to them.
There is a new word that's important to Spacelab, the POC. It stands for Payload Operations Control Center. It does for the payload what Mission Control does for the shuttle. Mission Control and the POC are in the same building at the Johnson Space Center in Houston. Mission Control handles the flying. Payload Control manages all scientific activities inside the Spacelab. You hear a lot about timelines around the POC. These detailed charts show graphically everything scheduled for each segment of the mission, which experiments are running, what each crew member is doing, where the orbiter's pointing, and a host of other details, down to the second. The flight of Spacelab 1 may be the most intense week of space research ever.
Got a problem with number 19. She thinks got a problem if they got something wrong with the battery charger.
Behind the control consoles in the payload control center are several rooms where investigators set up the equipment necessary to monitor their experiments. Much of the time, Spacelab is in satellite contact with Earth. Through the direct voice, TV, and data links, investigators can analyze their results and, if necessary, extend their hands and minds 135 nautical miles, right up to the laboratory bench.
Dave, can you bring me up to date on the status of the crystal growth experiment down at Kennedy?
All this activity wasn't orchestrated overnight. The mission manager has been responsible for planning and directing the Spacelab 1 mission. The mission manager and his team's prime goal is to ensure the Spacelab payload satisfies the research needs of the user scientists, that it uses the shuttle and Spacelab effectively, and that it operates well during flight. As the simulations draw to a close, the real thing begins. Clarity of observation lets us see the world in order to explain it. From orbit, we can see the universe without a veil of clouds. We can analyze phenomena without the bias of gravity. We can sample the complex forces and particles others thought to be empty space. As we move into orbit, our vision clears. Now we can go back again and again, learning from each flight experience, accumulating new knowledge. We have a new generation of orbiting laboratories. We have Spacelab.
Well, that was very atmospheric of the time.
Yeah, so I'll just drop, drop the share so we can go back to where we were normally. Okay, so we'll just have a look and see what we've got in terms of questions in the chat that you might be interested in answering.
So you might have noticed some illustrations that I showed on the slide in that clip as well.
Yes, that's right. And knee embraces, I made one comment about one airlock. Yeah, I think there was another second airlock in module 2.
Can't hear you, Wayne.
You can't hear me. Okay, sorry. I must be.
It's not very loud.
Can you hear me now? No?
You're
Can hear a little bit.
Sure what the problem is. Can you hear me now?
A bit.
We can hear what you're saying, but you're not very loud.
Well, you're going to have to accept that's the way it is. Okay. I haven't got enough time to stuff around with the sound. Thanks.
Okay. It's all right.
Too hard. Okay.
Did you want to show the craft work clip?
Let's do the questions first.
Question first. Okay. So
Lou's got a question.
Yeah. Lou?
Can I ask, was there information about why the module caught fire on landing and what how John Young handled it? Did you manage to...
Oh, okay, yeah. He managed to he realized that it wasn't going to be a dramatic event, so he kept from his experience. It was overloaded. It put itself out. It was auxiliary control computer, so it wasn't the main one. It was a backup. Okay. But the second one, they realized that the worst one was actually the fire it was a leakage of a chemical it was still burning when they landed. But they got out in time and put it out. Yeah, they traced it back to a leak. It actually ground the space shuttle for over a year while they fixed it all.
They had experience, knew what to do. It's good.
Yeah, well, it was only space shuttle STS-9, so they only had 9 flights. You know, these sort of things are going to happen, I suppose. What are the other questions there, Wayne?
Well, Ian was talking about the second airlock. That second airlock was used for payloads, I understand.
Yes, there was 2. Obviously, the first one was for the tunnel.
Yeah, that's
and there's one on top. There's 2. That looks like there's 2, but one's actually observation, and one next to it is the actual airlock. I think I mentioned that in my talk. They didn't use that on the talk that on the first mission, but it was for it was obviously for egress and ingress, and into outer space. I'm not quite sure what they use it for. I didn't look into the follow-up missions, but that's what it was for. Yes.
Whether they actually...
Well, for access to the pallets, I understand.
Yes. Well, it would have been that as well. Yep. So they could operate the pallets, because when the pallets were used, they didn't have the igloo, so that's why they had to get out. The igloo is only used when there was no one in the Spacelab.
Right, so they must have been just moving certain types of materials out onto the back open porch area, because I think that there even was space labs with no pressurized modules. There was a couple of them that just had pallets only, and that was towards the end of the shuttle program.
Yeah,
There
certainly were. There were more pallet. I think there were more pallet. I don't think the module ever flew without pallets, and there were 22 actual missions, Spacelab missions, and 16 of those are modules. So it's I didn't check, but I'm pretty sure most of those would have pallets. So pallets flew more than the Spacelab.
It's a couple of pallets only, but that gives you an indication as to how much NASA used it, though. If you said there was 20.
Oh yeah. In fact, they still use it in the ISS at the beginning.
Okay, a couple of the
but briefly I'm not quite sure what, but they did use an ISS when they were building it.
Yep, yeah, probably do some testing and maybe bring some payloads up.
Yeah. Well, I think the most they ever used in the space shuttle was 3 pallets. They built 5, but they never used more than 3 in one go.
Yeah, I think there were some missions, as I said, that used the 3. There was a telescope they were looking at one stage, but as you were saying, it's not pointing in the right direction. So although they were thinking about using some type of telescope at one stage, it wasn't going to work, based on the fact that it was pointing the opposite way most of the time.
I saw your comment.
Yeah, so, but I do remember the diagram showing the telescope, and then we realised later on that most of the time they had probably for thermal reasons to a degree with the radiators of pointing down towards the Earth. So the idea of putting a telescope in there was not going to.
Although the Spacelab was sufficiently insulated to be able to take full sunlight. So it could have.
More to do with the radiators. I think the way that they used to flying the heat profile with the shuttle was to turn it in such a way that the radiators would could exchange heat properly. So that's partly why they used to turn it down the opposite direction to try.
Oh, okay, right, yep.
That's a thermal reason. So if they had the telescope operating it, they wouldn't be able to point it consistently to the sky. The stars anyway, so it would probably limit the amount of astronomy it would do. So they might have worked out later it was not practical. And
I noticed you've said Owen Garrow flew on 2 Skylab missions. Okay, I thought he only flew on 1.
Skylab 2 actually. Sorry,
he did fly at least 1 Skylab, because it wasn't his first flight. And yes, John Young was a cool customer. Yes, I was. They would have been pretty glad to have him there. What else we got? Okay, I've got it from here. A very interesting call. Spacelab building the ISS. Yes, well, they used the pallets. The experiments were certainly ISS. They followed on for the experiments. In fact, some of my previous talks about growing plants in space, they were done in, a lot of those were done in Spacelab, and they were extended. Well, of course, the ISS was up there longer. The Spacelab was never more than a couple of weeks at the most. I don't know if the tunnel will ever be used in the Artemis moon base. Maybe. It's quite small. One just over a metre round. It's pretty squishy. I'm not sure if they would do the. Okay, how many flights? Yeah, there were 22 flights, and 16 of those were the module. So the pallets flew in 22 of those modules. The shuttle doors were obviously closed when they were taking off landing, and they were always open when they were in conducting missions. And I don't know if the military used Spacelab for military. That's probably a secret. Maybe I'm not allowed to know.
Well, they would never announce the military payloads.
No, that's what I'm saying. It's a secret, I'm sure.
There was at least 4 military missions, and they were not allowed to talk about what they were launching.
I suppose you just have to look up the missions, and the ones that didn't have very much information about them.
Maybe that's how they...
Yeah, they said they had.
I just said Spacelab. That's it.
Maybe, yes, it could be something in that, or some obscure unknown experiment.
No, there were.
Yeah.
Sorry, Kerry?
I was going to say there were military space shuttle missions, but I don't think Spacelab could ever have been used on a military mission because ESA was an aggressively civilian organization.
Ah, okay.
That's good to know.
They would have been very upset. I mean,
they
that's not to say there weren't a few defense-related experiments that were on some of the some Spacelab missions or some shuttle missions, but you wouldn't have had a military Spacelab mission, if I could put it that way.
If you want to know about how it used to work with military missions, all the crew had to be military.
Yeah, they all had to be serving military for the,
no civilian
for the defense missions
on the flight, and they all had to be actively in the military at the time. And the payloads were always classified. So there was some specific missions, and all that NASA would say was very vague about what was going on with the mission, and they would not even talk about the payload. There certainly was spy satellites launched in some of them.
Yeah, I think there's a couple of lacrosse satellites at least.
I think that's the lacrosse ones.
Launched with the shuttle. Yeah.
You know it that much, and that was it. Usually the crew was always 5, and there was basically that's how it worked, because they were quite heavy payloads that were going on there, so they wouldn't have ever put 7 in them. But that was how it worked. So there was at least 2 German-sponsored Spacelab missions. I don't think the first one was designated. I think there was a D1 and D2.
One of them was definitely D1. And I think you're right. I think it was a D2. I think actually I might be wrong. I think one of the Astro missions or one of the microgravity missions might have been German-sponsored as well.
Okay, as I say, I didn't look past the first mission because it's just too much to cover in one meeting.
Out of all the ESA stuff, they were always the most prominent, and because you said they had the control of the Spacelab, basically in the consortium, it was always pretty much their call, and they actually had quite a few payload specialists / astronauts. And the other 2 backups that you talked about on the first mission, they definitely flew.
Wubbo did. I actually worked on a space education project with him in the late 90s. And that was after he'd flown on the shuttle.
Yeah, I think he flew more than once as well.
I think you're right. I think he did. Yeah.
Over a long period, because there was quite a few. So, as I said, it was a very good topic that you chose, Ken, because of the terms of how important it was in the the way the shuttle was operating, because if it wasn't really for that, that was quite a good justification for them doing all the experiments, and that was usually the best way for them to pack a lot of experiments into the shuttle.
Yes, and of course ESA couldn't be more excited, pleased to try and get something themselves in there, because they couldn't afford to launch anything, but they certainly could get together and build Spacelab. So there was a pretty good marriage going on there between the two.